right, we're going to talk about function composition. So this is a way of combining two functions together and creating a new function. So the notation that we use for function composition is this f circle g of x. And I want you to recognize that this is not multiplication. So we're not multiplying these two functions together. We're sort of sticking one function inside the other. So another notation that we use is f of g of x. So when we read it, we say f of g of x. So we basically take the function g of x, we stick it inside the f function as the input. So the domain of a composite function, f of g of x, is all the x's that are in the domain of g and g of x. And in general, the order that you write them in matters. So f composed with g is different from g composed with f. They're not the same. So how do we evaluate composite functions? We begin by doing the inner function, and then we take what we get from there and work on the outer function. So if we want to evaluate g of f of 4, we have to begin by finding f of 4. So to find f of 4, we go to the input of 4, and we notice that the output is 1. So f of 4 is 1. So now what we're really evaluating is g of 1. So to find g of 1, we go to the input of 1, and we see that the output is 3. So in the end, g of f of 4 would be 3. So we did that with a table. Now let's see if we can do that with a graph. So how do we evaluate f of g of 5? Well, we begin by evaluating g of 5. So that is, use the graph of g at an input of 5. So we go to the graph of g, which is this graph here. We go to the 5 on the x-axis, and we notice that the output, or the y value, is 3. So g of 5 is 3. So now inside my f function, I have a 3. So now I want to find f of 3. So I go to the f graph, to the input value of 3, and I notice that the output value is the y value, 6. So f of g of 5 is going to be 6. Okay, so what do we do if we have equations? So this is f of h of negative 1. So I want to begin by doing the inside function, h of negative 1. So I'm going to take negative 1, I'm going to plug it into the h function anywhere I see a variable. So this is going to be 3 times negative 1 plus 2. Negative 3 plus 2 makes negative 1. So h of negative 1 turns out to be negative 1. So now inside here, my composition, I'm finding f of negative 1. So now I'm going to take negative 1 and plug it into the f function. So f of negative 1 is going to be negative 1 squared minus negative 1. Negative 1 squared is 1, plus 1 makes 2. So in the end, f of h of negative 1 is 2. What if I want to do it just in general in terms of x instead of in terms of a number, right? So the evaluation works exactly the same. If I want to find f of g of x, I'm going to take this g function and plug it inside the f. So f of g of x, which is 2 minus x. So everywhere in my f function, I'm going to replace it with a 2 minus x. So 3 times 2 minus x plus 1. So basically, you're taking that equation for g and sticking it inside of the f function. So 3 times 2 makes 6, minus 3x plus 1 gives me 7 minus 3x. So f of g of x is 7 minus 3x. Now I'm going to do the other direction, g of f of x. So now I'm going to take the f function, which is 3x plus 1, and I'm going to plug it inside the g function everywhere I see a variable. So 2 minus 3x plus 1. So 2 minus 3x minus 1. 2 minus 1 makes 1 minus 3x. So g of f of x is 1 minus 3x. Notice that these two things are not the same. The order matters when you're doing function composition.